You know, from the time we are like absolute toddlers, there is this one specific rule of survival that just gets drilled into our heads.
Oh yeah, above all others, really.
Right, above everything else. If you live in any kind of populated area, you definitely know this feeling. You step up to the curb, you stop, and you look both ways before crossing the street.
It's completely reflexive.
It is. It's basically encoded in our DNA at this point because, well, the street is an inherently hostile environment.
Oh, absolutely.
I mean, the street is where the 2-ton metal boxes are moving around. And if you are, flesh and bone, you really do not want to be in their way.
Right, it's the fundamental reality of the pedestrian experience.
Mm-hmm.
The ground level of our cities is dangerous by design.
Yeah, dangerous by design. I like that phrasing.
Well, it's true, because we have historically been forced to share our immediate physical space with massive, fast-moving, really heavy machinery.
But, okay, what if I told you that looking both ways is about to become, like, a relic? A quaint little historical quirk.
Like churning your own butter.
Yes, exactly. Like churning butter or dialing a rotary phone or, I don't know, physically rewinding a VHS tape.
Wow, rewinding a VHS tape. That dates us.
It really does. But think about it. What if the very concept of the street, as you and I know it, like a paved concrete corridor eternally choked with traffic, what if that is on the verge of total obsolescence?
I mean, hearing you say it out loud, it sounds like the setup to a science fiction novel.
It totally does.
But if you look at the capital, the engineering and the regulatory shifts happening right now, it is remarkably close to becoming the daily reality for everyone listening.
And that is exactly what we're getting into in today's deep dive. We've got a really fascinating, dense stack of sources in front of us today.
Yeah, a lot of great material here.
Anchored by this incredible analysis from Paramendra Bhagat, he is breaking down a highly prescient newsletter recently published by Peter Diamandis.
Right, the Diamandis piece is key.
And to pair with that analysis, we have these jaw-dropping conceptual urban blueprints and infrastructure visualizations, and the core subject of all this material.
The rise of eVTOLs.
Yes, the inevitable, rapid, and very real rise of electric vertical takeoff and landing aircraft. Or, as pop culture stubbornly insists on calling them flying cars.
The term flying car just refuses to die.
It really does.
Mostly because, it captures the imagination even if it's mechanically pretty inaccurate.
Oh, it's wildly inaccurate, but we all know what it means. Anyway, our mission today is to explore how these machines are about to take your incredibly frustrating two-dimensional mobility problem and turn it into a seamless three-dimensional solution.
Which is a huge paradigm shift.
Massive. We are going to look at why our massive ground infrastructure is about to look like a 20th century antique, and critically, why this reality is arriving much, much faster than anyone anticipates.
Way faster.
So, okay, let's unpack this, because for decades, the flying car has been like the ultimate broken promise of the future.
Oh, yeah, the classic retrofuturism joke.
Right, where's my flying car? It's a punchline.
Right.
But Diamandis and Bhagat are arguing that this is no longer a Jetsons myth.
No, not at all.
This is hard physics, it's aggressive economics, and the hardware is literally flying right now.
That is the crucial shift we need to make in our thinking today. And to understand why this is happening right now, we actually have to take a step back.
Okay, take me back.
We have to diagnose the fundamental flaw of how you and I currently move. Diamandis puts forward a really compelling central thesis here.
And that is?
That humanity has been trapped in a box for a century.
A box. And that box is basically the rigid surface of the Earth, right?
Exactly. The surface of the Earth is a severe two-dimensional constraint. Think about the incredible lengths we go to just to inch a little bit forward within this box.
Yeah, the amount of effort is wild.
We pave wider and wider roads, devouring massive amounts of valuable land, and when we inevitably run out of surface area because of induced demand.
Where building more lanes just invites more cars, right?
Exactly. You add a lane, traffic gets worse. So then we spend billions digging incredibly complex, dangerous tunnels.
Or we build those elevated rail lines that completely blot out the sun in a city.
Right. But no matter what architectural gymnastics we attempt, we are inherently limited by the physical geography and the geometry of the ground.
I look at it this way. It's like we've been trying to play a highly complex game of chess, but we are only allowed to use a single straight line of squares.
That's a great analogy.
You can't maneuver around obstacles. You just have to wait your turn or try to brute force your way through them. That's what gridlock is.
You're stuck in a line.
Exactly. But introducing the sky is like suddenly opening up the entire three-dimensional board.
It is the perfect geometric analogy. The advantage of the sky is profound because of its volumetric capacity.
Volumetric capacity, meaning just the sheer amount of space.
Right. The sources point out that once you get above a few hundred feet, the sky is essentially an infinite three-dimensional superhighway in every single direction.
Which is hard for our ground-dwelling brains to wrap around.
It is. But think about the friction you experience on your daily commute.
Mm-hmm.
In the sky, there are no lanes. There are no four-way intersections. There are no traffic lights, no potholes, no construction zones, and obviously no pedestrians to watch out for.
It is straight line freedom.
Straight line freedom.
Yeah.
You move point to point from almost anywhere to almost anywhere else, calculating the literal shortest distance between A and B.
And the cost of staying in our 2D box is just staggering. It's not just an annoyance, right? It is a massive economic drain.
Huge.
The sources mention the traditional transport infrastructure demanding trillions of dollars. Trillions! With a T.
Yeah, it's hard to even fathom that number.
We are talking about concrete, steel, continuous maintenance, the massive environmental cost of laying all that asphalt.
And the invisible taxes, too.
Yes. For you, the listener, think about the invisible tax of your time sitting in gridlock, staring at the bumper of the car in front of you.
Furthermore, that fixed infrastructure locks us into incredibly rigid corridors. Ground transit, even the absolute best public transit systems in the world, dictates where you can live and where you can work.
You are geographically chained.
Chained is the right word. You have to be near the train line or you have to endure the highway commute. Your entire life is organized around these static arteries of concrete and steel.
Okay, well, I have to push back a little here. Or, at least ask the obvious question that I think anyone listening is probably yelling at their steering wheel right now.
Bring it on.
We have always known the sky was up there. Like, it hasn't moved. The geometry of the sky has been infinite since the dawn of time.
True.
So why was this just a dream until now? I mean, if the 3D board is so vastly superior, why have we been playing 1D chess for the last 100 years? What actually makes today different?
That is the vital question. The sky was always there, yes. But the technology to access it quietly, safely, and economically was absolutely not.
Ah, okay.
What makes today different is the vehicle itself. The evolution of the eVTOL.
The electric vertical takeoff and landing vehicle.
Exactly. And we really have to clarify what this machine actually is, mechanically speaking. Because when people hear flying car, they often picture like a sedan with wings bolted onto the doors.
Like the DeLorean from Back to the Future.
Right, or a really loud, incredibly clunky helicopter. But an eVTOL is essentially an advanced, highly scaled-up electric drone.
And looking at the specs in these sources, that drone distinction is everything. It literally changes the entire physics of the conversation.
It does.
I want to talk about the noise factor first, because this was my biggest assumption going in, and frankly, my biggest fear about this whole topic.
The noise pollution argument.
Yeah. I assumed a sky full of flying cars would sound like an active war zone. I pictured the concussive, window-rattling thwack, thwack, thwack of a news helicopter, right? But multiplied by 10,000 over a city.
Which would be unbearable.
Completely unlivable. But I was looking at this stat from Joby Aviation in the source material, and it genuinely blew my mind. Their aircraft cruises at just 45 decibels.
Which is astonishingly quiet for any vehicle, let alone an aircraft moving at 200 miles per hour.
45 decibels is library-level quiet. It is the sound of a quiet suburb at night. It's the hum of your kitchen refrigerator. The source explicitly notes that it is 100 times quieter on takeoff and landing than a traditional helicopter.
What?
100 times. Physics is physics. How do you silence spinning blades lifting thousands of pounds into the air?
Well, you silence it by changing how the thrust is actually generated.
Yeah.
And this completely shatters the primary argument against urban air mobility.
Okay, break that down for me.
So helicopters rely on a single massive combustion engine turning an enormous main rotor.
Right, the big blade on top.
Exactly. That massive blade has to displace a huge amount of air very violently to create enough lift. That creates a massive acoustic signature.
Okay.
The tip of a helicopter blade is often breaking the sound barrier, which creates that concussive thumping noise we all feel right in our chests.
Right, it's brute forcing the air.
It's totally brute force.
Yeah.
eVTOLs, on the other hand, use distributed electric propulsion.
Distributed electric propulsion, so spreading it out.
Yes, they have multiple smaller electric motors distributed across the wings and the airframe. These smaller rotors spin at different variable speeds. By utilizing many smaller blades, they don't have to displace as much air per blade. And Incredibly, they can actually use phase-shifting acoustics to have the sound waves cancel each other out.
Wait, really? The sound waves cancel each other out? That's wild.
It's brilliant engineering. Add to that the fact that electric motors themselves are virtually silent compared to a screaming turbine engine.
Of course.
So the noise pollution problem, which is the entire reason we don't allow helicopters to land on every single building today, is essentially solved by the physics of electric propulsion.
Okay, so the physics of the noise is solved. It's a whisper in the sky. But what about safety?
Safety is paramount, obviously.
Because a sky full of these things sounds like an air traffic controller's absolute worst nightmare. If we take human drivers, who are already notoriously terrible at navigating in 2 dimensions,
Don't remind me.
right, and we give them a 3rd dimension to crash in, I mean, yikes. What happens when a sudden microburst of wind hits one of these things over a densely populated area?
Well, what's fascinating here is that the eVTOL revolution isn't waiting on a single miracle breakthrough in human piloting.
What do you mean?
It is the convergence of electric efficiency, drone mechanics, and to your point about safety, autonomous software meeting at scale.
Okay.
Because these vehicles are fundamentally digital fly-by-wire machines, they don't rely entirely on a human desperately pulling levers. They leverage the massive leaps in AI safety that we are already seeing on the ground.
Right. The sources specifically reference autonomous driving data here, don't they?
Yes, the source cites Waymo's 92% crash reduction compared to human drivers in ground-level robotaxis.
92%. That is massive.
It is. Now, take that AI capability and put it in the sky. And counterintuitively, the sky is actually an easier, vastly more predictable environment for an autonomous system to navigate than a busy city street.
Okay, I hear you saying the sky is predictable, but I really have to push back on that.
Go for it.
How is the sky easier? There are no lines painted on the clouds. How does an AI know where it's going without a road?
Think about the variables an AI has to process on the ground.
Okay.
On a street, you have kids chasing balls, unpredictable cyclists swerving, a delivery truck suddenly backing out of a blind alley, black ice, pedestrians staring at their phones.
Basically endless chaos.
The variables are infinite and deeply chaotic. But in the sky, you have a highly controlled, incredibly vast open space. AI doesn't rely on painted lines. It relies on GPS, LiDAR, and continuous digital communication.
Oh, I see.
Think of traditional air traffic control like a human trying to conduct a symphony by pointing at each musician one by one.
Very slow, very stressful.
Exactly. AI orchestration is like having sheet music that dynamically rewrites itself 1,000 times a second. Every single vehicle in the sky is constantly broadcasting its exact trajectory, speed, and wind resistance to every other vehicle in the network.
Oh, wow.
The AI coordinates thousands of these vehicles simultaneously, keeping them in stacked vertical corridors with perfect mathematical separation.
Okay, that makes sense. So the vehicles are ready, the physics work, they are electric, they're incredibly quiet, and they have these hive mind AI safety protocols baked right into their DNA.
Correct.
But that brings us to a massive practical logistical question.
Which is?
If I have this whispering electric drone car, where does it actually go?
The infrastructure piece.
Yeah, because we've got this great 3D superhighway, but eventually you have to come back down to the 2D world. You can't just land a Joby aircraft in the grocery store parking lot between a minivan and a shopping cart return.
No, definitely not. The sky is completely useless without access points. And this leads us to the radical shift in physical infrastructure that Diamandis and Vigat are pointing to. It's the concept of the vertiport.
Vertiports. We have some incredible visualizations of these in our sources, and let's walk through them because this really helped me understand the scale of the change.
The visuals are really helpful.
When we think about traditional aviation infrastructure, we instantly think of airports. And airports are massive.
Gargantuan.
They require square miles of flat land, massive 2-mile runways, terminal buildings the size of shopping malls, and incredibly complex fueling infrastructure.
And even ground transport requires massive footprint.
Yeah.
Think of the sheer acreage of a train yard or a major highway cloverleaf interchange.
Oh, yeah. So much concrete.
But vertiports operate on a completely different geometric scale. They are measured in square meters, not square miles.
Let's look at the first image provided in the sources, the Atlantic vertiport concept.
Oh, this is a great one.
I'm looking at this, and honestly, if you didn't tell me what it was, I wouldn't guess it's an aviation facility. It doesn't look like an airport at all.
What does it look like to you?
It looks like a high-end corporate plaza or like a very nice modern park. It's a landing pad that seamlessly integrates right onto a rooftop or maybe a repurposed urban heliport.
Right.
And the passenger lounge, it is the size of a small cafe. It's just a sleek, minimalist glass enclosure with a green roof sitting right next to these landing circles.
That image perfectly encapsulates the microinfrastructure revolution. Because the eVTOLs take off and land vertically, they simply don't need runways.
Which saves so much space.
It eliminates 90% of the land requirement right there. Furthermore, because they are electric, they don't need massive, highly flammable jet fuel storage tanks, underground pipelines, or specialized fueling trucks.
That's a huge safety and space benefit.
Huge. They just need a solid, load-bearing surface and a high-capacity electrical charging hookup.
But wait, if we are talking about high-capacity charging, doesn't that strain the city's power grid? I mean, you have dozens of these things landing and sucking up electricity all at once.
It requires grid upgrades, certainly, but vertiports are being designed with massive localized battery buffers.
Okay, so they store the power on site.
Exactly. They trickle charge from the grid all day, storing the energy on site, and then dump that energy rapidly into the eVTOLs when they land. This prevents massive spikes in grid demand.
Oh, smart.
And that rapid charging is crucial to the entire economic model.
Right, the turnaround time mentioned in the sources is wild. These vehicles land, recharge, and lift off again in under 20 minutes. 20 minutes.
It's incredibly fast.
That's less time than it takes me to find parking at a stadium.
It's a completely different operational cadence from traditional aviation. It's not about parking a massive aircraft at a gate for 3 hours while it's cleaned, fueled, and catered.
Yeah, no baggage carts driving around.
Right. It's about continuous fluid movement. The aircraft only makes money when it's in the air, so the infrastructure is designed to get it back up immediately.
You know what it reminds me of? It reminds me of the shift from mainframe computers to smartphones.
Oh, that's a brilliant comparison.
Right. We used to need these massive climate-controlled, centralized rooms to house a single computer that a few people could use. The infrastructure dictated the access.
Yep.
Now the network is distributed and everyone has exponentially more power right in their pocket. We are witnessing the miniaturization and distribution of civic infrastructure.
We really are.
We are taking the massive logistical capability of an airport and shrinking it down to the footprint of a neighborhood coffee shop.
And that miniaturization is the key to why this scales so fast economically.
Why is that?
Building a new subway line in a major city can cost over $1 billion per mile. And it takes a decade of digging. Building a vertiport on top of an existing parking garage or a retrofitted skyscraper roof is a fraction of that cost, and it can be done in months.
Wow. We also have another image in the sources showing a much larger vertiport, but this one is integrated into a major airport.
Let's talk about that one.
Let me describe this for you, the listener, because it shows how this futuristic tech bridges the gap with our existing messy reality.
It's a great visual.
It looks like a massive international airport. Think JFK or LAX, but right in the center, hovering directly over the main terminal complex, is this incredibly compact, multi-pad hub. It looks almost like a flower with 6 petals, and each petal is holding an eVTOL.
Right, perched right on top.
Exactly. And it's situated right above all the ground transit, the monorails, the highways, the parking structures.
That image brilliantly illustrates the concept of multimodal integration. Imagine the typical travel experience.
Okay, I'm imagining it. It's usually stressful.
You fly into a major airport on a traditional commercial jet from across the world. You land, get your bags, and then you face the worst part of the journey.
Getting to the city.
Yes. Spending an hour and a half fighting brutal highway traffic in a taxi just to get to the city center. But in this multimodal model, you get your bags, take an elevator up to the roof of the terminal, board an eVTOL, and you are dropped directly into downtown in 10 minutes, completely bypassing the highway.
That sounds like magic. And what's wild is that the regulatory aspect of this, the actual legal right to fly these things over cities, is a hurdle that is already mostly cleared.
Surprisingly, yes.
The sources point out that the airspace above cities is already heavily regulated and mapped out. We already have rules for the sky.
Precisely. We aren't starting from scratch legally. Scaling that existing airspace to accommodate high-frequency air taxes is vastly cheaper and faster than trying to use eminent domain to buy up densely populated neighborhoods to expand a single ground-level highway.
Oh, good luck expanding a highway in a city today. It takes 20 years in court.
Exactly. The regulatory framework needs updating to handle the volume and the autonomous aspects, yes. But the physical space is already there, it's public, and it's waiting to be utilized.
Okay, so we have quiet autonomous vehicles, and we have cheap modular rooftop vertiports. The physics and the infrastructure are solved in theory, but physics doesn't build fleets. Massive amounts of capital does.
That is the truth. Follow the money.
Right. To see if this is actually real, we have to follow the money and see who is actually passing the gauntlet of aviation regulators. Let's talk about the heavyweights. Who is actually building this future?
The landscape has shifted a lot recently.
Because the source material points out that while there were over 500 contenders worldwide dreaming up flying cars a few years ago, the field has aggressively narrowed down to about 20 serious players.
And out of those 20, there is an elite handful leading the charge toward commercial reality, with timelines that are frankly astonishing.
How fast are we talking?
As of the source's reference point in April 2026, these companies are no longer in the conceptual drawing board phase. They are in the rigorous, unforgiving certification and deployment phase.
Wow. Okay, let's start with the U.S. frontrunner. Joby Aviation. These guys seem to be the absolute heavy hitters domestically.
They really are.
Their S4 aircraft carries 1 pilot and 4 passengers. It cruises at 200 miles per hour, which is blazing fast for an urban commute, and it has a 150-mile range.
That specific range and speed combination is critical. It defines the operational sweet spot for this entire industry, which we will get into shortly.
Okay, note.
But look at their operational status. Joby has already completed testing of its first FAA-conforming production aircraft. They aren't flying little remote-controlled scale models. They've flown full-size demo flights over the Golden Gate Bridge.
That's amazing.
They are in Stage 4 of the FAA's rigorous 5-stage certification process.
Stage 4 out of 5, that is right at the finish line. And their business moves are just as aggressive as their engineering.
Absolutely.
They realize they aren't just building planes, they have to build the entire network. They partnered with Uber for Uber Air services to integrate into an app people already have on their phones.
Which is brilliant user acquisition.
Totally. They actually acquired Blade Air Mobility's passenger routes, basically buying up the most lucrative existing helicopter routes in places like New York to get instant turnkey infrastructure.
Very smart move.
And perhaps most importantly to their long-term survival, they have Toyota as a major manufacturing partner.
That Toyota partnership cannot be overstated in its importance.
Why is that the game changer?
In the aviation world, there's a saying, building a beautiful, functioning prototype is hard, but manufacturing that aircraft at scale perfectly, thousands of times over, is exponentially harder.
Right, mass production is a whole different beast.
Aerospace companies traditionally build things slowly, by hand. Automotive companies build things rapidly on assembly lines. Toyota brings that peerless mass manufacturing expertise to Joby.
Oh, that makes so much sense.
And their timeline reflects that confidence. Commercial launch in Dubai is targeted for as early as 2026, with U.S. pilot program flights starting the summer of 2026.
Summer of 2026. That is essentially tomorrow in aerospace terms.
It really is.
Now, right on Joby's heels is another U.S. company, Archer Aviation. Their aircraft is called the Midnight.
The Midnight, yes.
It also holds 1 pilot and 4 passengers, but it's optimized a bit differently. It's slightly slower at 150 miles per hour with a shorter 60-mile range. They're clearly targeting those rapid, back-and-forth, high-frequency urban hops rather than long regional flights.
Archer is a fascinating case study in aggressive, pragmatic commercialization. They are the first U.S. company to secure 100% FAA acceptance of their means of compliance.
Wait, pause right there. Means of compliance. For anyone listening who isn't an aviation lawyer, that sounds like typical bureaucratic word salad. What does that actually mean in the real world?
It's a massive regulatory milestone. When you build a totally new category of aircraft, something that isn't a plane and isn't a helicopter, the FAA doesn't have a textbook on how to test it.
Right, because it didn't exist until now.
Exactly. They don't know what the stress test should look like because the machine didn't exist 5 years ago. Getting means of compliance fully accepted means the FAA has officially agreed on the exact specific tests Archer has to pass to prove the aircraft is safe for the public.
Okay, I follow.
They aren't in a vague back-and-forth negotiation anymore. The goalposts are finally locked in place.
So they aren't just making up their own homework anymore. The teacher has handed them the final exam rubric, and they just have to score 100.
Exactly. And the broader market deeply believes they will pass that exam. Archer has a massive $6 billion order backlog, which notably includes significant orders from United Airlines.
Right. United Airlines buying in is a huge institutional validation. It means legacy aviation sees this as a threat they need to own.
Yep. They want a piece of the pie.
And Archer is the official air taxi provider for the 2028 LA Olympics. They even bought Hawthorne Airport near LAX to serve as a physical hub. They are literally buying the ground infrastructure to ensure they have guaranteed places to land when the crowds descend on Los Angeles.
And both Joby and Archer are deeply involved in the FAA's 26-state eVTOL integration pilot program, the EITP, which begins real-world operations in the summer of 2026.
Okay.
This is where the theoretical physics and the PowerPoint economics meet the practical reality of U.S. airspace.
But while the U.S. is pushing hard with piloted vehicles, forcing a human to sit in the front seat to appease the FAA, we really have to look globally here.
We do.
Because the actual pioneer here, the company that might beat everyone to the punch globally, might be EHang.
Yes, the geopolitical contrast in approach is striking here. EHang is based in China, operating the EH216S, and unlike Joby and Archer, EHang's vehicle is fully 100% autonomous.
Wow.
There are no manual flight controls,
Yeah.
no pilot on board. It is essentially a two-passenger drone-like pod.
And they aren't just testing. The source says they are the world's first fully certified autonomous eVTOL, having received official type certification from China's SEC, their equivalent of the FAA back in 2023.
Way ahead of the curve.
They have logged over 40,000 test flights, and this is the kicker that blew my mind. They are generating revenue right now.
Today.
Yes. In Q1 2026, they are running ticketed sightseeing flights in cities like Guangzhou. Wait, pause. You're saying right now, as we speak, a regular person can buy a ticket, get into a drone with no pilot, and fly over a major city in 2026?
That is exactly what is happening.
How did China bypass the decades of red tape the U.S. is currently wading through?
This represents a massive divergence in regulatory philosophy between the East and the West.
Explain that.
The U.S. approach via the FAA is intensely cautious. They are insisting on piloted operations first to slowly integrate into existing airspace norms. They want to prove the hardware works with a human fallback before they even touch full autonomy for passenger flights.
Which makes sense from a traditional safety standpoint.
It does. China, however, has made what they call the low-altitude economy a massive national strategic priority. The regulators have worked hand in glove with EHang to leapfrog the piloted phase entirely and go straight to fully autonomous passenger flights.
It feels like an absolute space race for the sky.
It really is.
The U.S. companies have superior range and speed for longer commutes, but EHang has the autonomous certification and actual paying passengers today?
It is a global race, and it includes a deep bench of others too.
Who else is in the mix?
Well, the sources briefly touch on Lilium in Europe, who are aiming for a larger six-seater regional jet design, using ducted fans instead of open propellers. There's Vertical Aerospace in the UK with massive airline pre-orders.
Okay.
Volocopter in Germany is already running sandbox trials. Eve is heavily backed by the aerospace giant Embraer, and Wisk is wholly owned by Boeing, which is pursuing a hybrid approach of starting autonomous from day one, but with human supervisors on the ground.
Interesting.
And companies like Beta and Electra are focusing smartly on cargo and hybrid electric use cases first.
The massive takeaway here is that the heavyweight aerospace legacy companies, Toyota, Boeing, Embraer, United Airlines, they're all pouring billions into this.
Absolutely everyone is involved.
This isn't a fringe hobbyist movement of tech bros in a garage. This is the new aviation establishment.
Exactly. And with fleets launching commercially in 2026 and scaling up massively for global events like the 2028 Olympics, we really have to transition from the boardroom to the street.
What do you mean?
We have to ask, how will this actually change the daily reality for you, the average person listening right now, living in a city?
Right. Let's move from the hardware specs and the corporate maneuvering to the human impact. The source material calls this the metro moment.
I love that term.
Now, I love a good subway system. I live in a city with one. It works. So are these flying cars going to replace my morning subway commute from my apartment to my office a few miles away?
No, and that is a crucial pragmatic distinction made in Fogat's analysis.
Okay.
eVTOLs deliver metro-level transformation with 21st century elegance, but they are complementing, not replacing, existing high-density ground transit.
Yeah.
If you are going 3 blocks down a densely packed urban corridor like Manhattan or central London, you will still take the subway or you will walk.
Makes sense.
It doesn't make sense to fly a mile.
So where do they actually fit in? Where does this technology flex its muscles?
They completely dominate the last mile gap, or more accurately, the 20 to 100 mile gap. That is the geometric and economic sweet spot for these vehicles.
Ugh, the 50 to 150 mile sweet spot. Here's where it gets really interesting for anyone dealing with a commute. The sprawling, soul-crushing daily reality of modern megacities.
That's awful.
The sources give great examples. Commuting from Los Angeles to San Diego, traveling from New York City to the Hamptons, London to Birmingham, the Shanghai suburbs to the Central Financial District.
Iconic, terrible routes.
On the ground right now, those routes are absolute torture. You're fighting fixed roads, unpredictable traffic signals, endless construction, and thousands of other frustrated drivers. It's a 2-hour drive on a good day and a 3-hour nightmare on a bad one.
We've all been there.
Yeah.
But in an eVTOL, traveling at 150 to 200 miles per hour in a straight line, that 2-hour grueling drive becomes a pleasant, highly predictable 20-minute aerial hop.
20 minutes instead of 2 hours.
It goes back to that straight line freedom we discussed earlier. And as these fleets scale up, the economics shift dramatically.
This is the part that really got me.
The sources cite an incredibly aggressive ARK Invest projection that the cost to the consumer will eventually drop to somewhere between 20 and 40 cents per mile.
Okay, I have to stop you again. 20 to 40 cents per mile.
It's wild, isn't it?
That is cheaper than taking an Uber on the ground today. It's cheaper than the IRS mileage reimbursement rate for driving your own car. How on earth is a flying machine cheaper to operate than a Toyota Camry? Break down the unit economics for me.
It comes down to two major factors: mechanical simplicity and high utilization rates.
Okay, let's start with simplicity.
First, mechanical simplicity. A traditional combustion engine helicopter has thousands of intricate moving parts, complex gearboxes, massive swash plates, turbine blades. They require intense, constant, wildly expensive mechanical maintenance.
They are maintenance nightmares.
They are. For every hour of flight, a helicopter might need 3 hours of maintenance. An electric motor, by contrast, has maybe a dozen moving parts. It's basically a magnet spinning around a coil.
Wow.
There is almost zero maintenance downtime.
So because it doesn't break down, it can just fly constantly.
Exactly. That leads to the second factor, utilization rate. Because the eVTOL doesn't need to be in the shop, and because it can recharge in 15 minutes, it can fly, charge, and fly again, doing dozens of trips a day, back to back.
Like a machine. Well, it is a machine.
Right. An Uber driver has to sleep. An autonomous eVTOL does not. It can run 20 hours a day. When you spread the capital cost of the vehicle across hundreds of trips a week, the cost per mile plummets.
That makes so much economic sense.
Once that utilization soars, it moves from being a luxury toy for the rich to a true mass transit option. It becomes an aerial Uber.
So if you are listening to this, what does this all mean for where you actually choose to live your life? If a 100-mile trip takes 20 minutes and costs $30, that changes everything about your geography.
It leads to a fundamental society-wide repricing of real estate.
Explain that.
Right now, your property values are heavily dictated by proximity to ground transport corridors. How close are you to the highway on-ramp? Are you walking distance to the train station? How close are you to the downtown core?
Right. Location, location, location.
Exactly. But if the time penalty of distance essentially evaporates, the entire map is redrawn.
I'm thinking about the second-order effects of this. Waterfront properties, remote islands, mountain cabins, deep rural suburbs.
All of it.
Places that were previously considered strictly weekend retreats because they were a 3-hour drive away. They suddenly become entirely viable for a daily 25-minute commute.
Altitude accessibility becomes the new metric for value. If your suburban community or your corporate off-let park installs a vertiport, you are instantly physically connected to the entire regional network. The old real estate adage of location, location, location takes on a vertical, volumetric dimension.
It's mind-bending. You could live in the serene quiet of the mountains and work in the dense heart of the city, and the commute would literally be the easiest part of your day.
It sounds idyllic.
But so far, we are just talking about retrofitting our old legacy cities with these landing pads, squeezing vertiports onto old parking garages. What happens when you don't have to retrofit? What happens when you build a city from scratch, knowing from day one that the sky is your primary highway?
This is perhaps the most profound and disruptive part of Diamandis's vision. When urban planners are handed a blank canvas, completely free from the baggage of 20th century concrete infrastructure, the results are revolutionary. We are talking about the dawn of skyborne cities.
Skyborne cities. The sources specifically mention EO in Saudi Arabia and new smart cities springing up in the UAE.
Yes.
Because they don't have legacy highways to maintain or massive suburbs to rip out, they are designing for the third dimension immediately. And we have this incredible image in the sources of what a skyborne city looks like.
It's breathtaking.
I want to describe this for you, the listener, because it is literally a utopia compared to whatever commute you did this morning.
Please do. The visual impact of that concept is striking, and it clarifies the end game of this technology.
Okay, looking at this image, well, the absolute first thing that hits you is what isn't there. There are no roads for cars on the ground level, none.
Zero asphalt.
No massive heat-trapping parking lots swallowing entire city blocks. No bus lanes, no traffic lights, no gridlock. Instead, the ground level is just returned to humanity.
It was so peaceful.
It really does. It is a paradise of massive pedestrian promenades. It's lush. There are green parks everywhere, sweeping bike paths, open plazas with people gathering. The buildings themselves are draped in greenery with these beautiful curved terraces that look almost organic.
And where is the transportation infrastructure?
It's entirely in the sky. Above these green towers, the sky is actively mathematically orchestrated. You see dozens of these sleek eVTOLs. Some look like the winged Joby drones. Some look a bit more like the EHang passenger pods flowing seamlessly.
It's a beautiful vision.
The source describes them as moving in stacked, invisible vertical corridors overhead, managed flawlessly by the AI network we talked about earlier.
This represents the ultimate reclamation of urban space. Traditional American metros waste an astounding, almost criminal amount of their total landmass on cars.
How much space are we talking?
We are talking 30 to 40% of a city's footprint dedicated purely to roads, driveways, and parking lots.
That is insane.
Imagine taking 40% of a city like Los Angeles or Dallas or Atlanta and instantly converting all of that concrete into affordable housing, public parks, and community spaces.
It would completely transform the feeling of living there.
Urban density can increase dramatically without any of the claustrophobia or the crippling ground congestion we associate with density today.
In a skyborne city, your transportation choices become a very simple, elegant binary. You either walk or bike 5 minutes for your local, neighborhood needs groceries, the local cafe, the park, the gym, or you fly for absolutely everything else.
Exactly.
You just walk a few steps to the nearest vertiport, seamlessly integrated into your apartment building, you hop in an autonomous pod, and you're whisked across the city.
This raises an intensely important question, though, a highly disruptive geopolitical one.
Okay, what is it?
If the Gulf states and parts of Asia prove this model works, if they actually build these skyborne hyperlivable cities by the early 2030s, how will our legacy gridlocked Western cities adapt?
Oh, wow. I hadn't thought of the macroeconomic angle. You're talking about a massive competitive disadvantage for places like New York or London.
Exactly. Capital goes where friction is lowest.
Right.
If you are a top-tier professional, a brilliant engineer, or a major multinational corporation deciding where to place your headquarters, you have a choice.
And the choice is stark.
Right. You can operate in a legacy city where your employees lose 2 hours a day in miserable, smoggy gridlock, paying exorbitant taxes just to maintain crumbling bridges. Or you move to a new city where the air is clean, the ground is a sprawling park, and any crosstown commute is a 10-minute, whisper-quiet aerial hop. Where do you go?
You go to the skyborne city, absolutely. It threatens massive brain drain and capital flight from legacy cities if they refuse to adapt. If the wealthy and the highly skilled can just abandon the ground-level chaos for a better quality of life elsewhere, what happens to the municipal tax base of our current cities? It forces the hand of every mayor, every governor, and every urban planner in the world.
They have to act.
You either integrate this 3D technology, or you watch your city wither and get left behind in the 20th century.
The transition will undoubtedly be incredibly challenging for older cities. They have to manage complex airspace over dense populations. They have to ensure equitable access so this doesn't just become a helicopter service for the ultra-rich. And they have to completely rewrite century-old zoning laws to allow for vertiports.
It won't be easy.
No. But the geometric, environmental, and economic advantages of moving to the third dimension are so overwhelmingly powerful that the transition is completely inevitable.
It really is an absolute paradigm shift. It rewrites the rules of geometry that we've lived under since the invention of the wheel. Okay, let's bring this all together.
Let's do it.
We started this deep dive talking about the limits of our two-dimensional world, a rigid constraint that demands trillions of dollars in asphalt and literally steals hours, days, and weeks of our lives while we sit behind the wheel.
And we've seen how the convergence of multiple exponential technologies is shattering that 2D constraint.
Right.
Distributed electric propulsion, silencing the noise, autonomous AI orchestrating the safety, and vertical takeoff technology shrinking the infrastructure.
Yeah.
We are actively moving toward a 3D AI-orchestrated, battery-powered sky.
It is whisper quiet. Thanks to high utilization and low maintenance, it is rapidly becoming cost competitive with the Uber you take on the ground today.
And it's happening now.
Yes, with heavyweights like Joby, Archer, and EHang holding massive capital backing, locking in regulatory approvals, and running actual pilot programs and commercial launches as early as 2026, it is happening right now. It's not a flashy computer render in a tech blog. It is physical hardware operating in the sky today.
The hardware is real.
So, to you, the listener, the next time you are sitting in bumper-to-bumper gridlock, gripping the steering wheel, staring at a sea of red taillights, just take a second and look up. Look at the empty space above the highway. Because the solution to your frustration is already certifying, it's doing test flights overhead, and it's getting ready to land on a roof near you.
And as we look forward to integrating that reality into our daily lives, I want to leave you with a final thought to mull over. A second-order effect that goes beyond just the vehicle itself.
I love these. Lay it on us.
If an eVTOL turns a grueling, stress-inducing 60-mile commute into a pleasant 15-minute aerial hop where you can read a book, we're no longer going to measure our world in physical distance. We will soon measure our world purely by time.
Measuring by time, not distance.
Exactly. When anywhere within a 100-mile radius is just 15 minutes away, how will that fundamentally change the trajectory of your life? Who will you choose to work for when the office can be 100 miles away? Where will you decide to send your kids to school? Or what will you even consider to be your local community when your neighborhood spans a 3-state radius? The future of human mobility isn't coming slowly down the road. It's already lifting off.
And when it truly scales, looking both ways before crossing the street might just be the strangest, most antiquated thing you could possibly do.